In this lecture, we will motivate the need for a more refined logic called predicate logic that will then be introduced in subsequent lectures. Recall that the purpose of logic is to study what is correct logical reasoning. Let's see an example of an argument. If Alfred is a duck, then Alfred can swim. Alfred is a duck, so Alfred can swim. You can use propositional logic to analyze whether this argument is correct from a logical perspective. The idea is then to introduce proposition variables for the smallest propositions that occur in the argument, recognize that the first premise is an implication, the second premise is a simple proposition variable, and see that actually the proposition variable B is a logical consequence from the implication A implies B and the left-hand side of the implication A. So propositional logic confirms that the argument we give here is correct from a logical perspective. Now consider the following adaptation of the argument. Suppose that we start with the implication again, but then instead of the left-hand side of the implication, we put as a premise the right-hand side of the implication, the B. Then concluding from these two premises, if Alfred is a duck, then Alfred can swim, and Alfred can swim, that Alfred is a duck is logically invalid. And in fact, this is also confirmed by propositional logic. From the implication A implies B and the proposition B, we cannot conclude, we do not have as a logical consequence that A holds. So propositional logic confirms that this is an invalid logical reasoning. Now let's have a look at the following refined argument. Every animal with feathers is a bird. Alfred is an animal with feathers, so Alfred is a bird. Now also this reasoning seems to be correct from a logical perspective. But if we try to analyze it using propositional logic, we run into problems. Because, well, the smallest logical constituent in the first premise is the whole sentence. Every animal with feathers is a bird has to be represented by a single proposition variable in propositional logic. And Alfred is an animal with feathers would be another proposition. It doesn't have any smaller logical constituents. And Alfred is a bird would be a third proposition with a third proposition variable introduced for it. And clearly, A and B does not have as a logical consequence a C. So propositional logic would say that this argument is false. From A and B, we cannot conclude C. But still, our feeling is that this is a valid logical argument. So we need a more refined logic to talk about the structure of these sentences. Propositional logic is too coarse-grained to motivate the correctness of this reasoning. The culprit is that propositional logic does not allow us at all to consider or represent the internal constituents of a statement if it is itself not composed of statements. What is important for the reasoning here is that both premises are about individuals, in this case animals with feathers, that may or may not have certain properties. The first sentence expresses that all such individuals enjoy the property of being a bird. The second sentence expresses that Alfred is the name of a particular individual that is to be considered an animal with feathers. Let's have a closer look at the internal structure of the second sentence first. It refers to an individual by the name Alfred and states that this individual satisfies a certain property. It is an animal with feathers. Next, let us consider the first sentence of the argument. It involves another property of individuals, that of being a bird. And it involves a quantification of individuals, in this case, all animals with feathers. Now we have a more refined view on the structure of the sentences that make up the argument. We can abstract from the contents without throwing away the structure altogether. The argument then takes the following logical form. Representing being an animal with feathers by P and being a bird by Q, the first premise of the argument becomes every individual satisfying P also satisfies Q. Considering Alfred as a particular individual referred to by I, the premise of the argument becomes individual I satisfies P. And then the conclusion of the argument reads individual I satisfies Q. Now this is the kind of argument that can be justified in predicate logic, which we shall discuss in the next couple of lectures. Predicate logic extends propositional logic with the following ingredients. It introduces the notion of an individual. We shall not spend a lot of time discussing on how to specify individuals. Usually we shall just introduce names like Alfred in the example we have given before. Or, as it is common in mathematics, we use expressions to denote individuals. Predicate logic also introduces the concept of a predicate, which allows us to specify properties of individuals. And it introduces the concept of quantification. Predicate logic has two quantifiers, the universal quantifier to specify for all, and the existential quantifier to specify there exists. Quantifiers are introduced in the form of variable binding constructs, which makes them fairly involved from a technical perspective. So we shall spend a couple of lectures discussing quantification and explaining it carefully. We have now motivated the need for the more refined language of predicate logic. In the next couple of lectures, we shall discuss this logic in more detail.